In this video, we're going to go over another trig limit example, and this one's going to involve U-substitution. So, we're interested in finding the limit as x tends to 2, x squared minus 4x plus 4 divided by sine squared of x minus 2. Now, hopefully you remember that sine squared of x minus 2 is the same thing as sine of x minus 2, the quantity squared, the entire thing squared. So go ahead and rewrite it that way here. It's minus 2 squared. So we're not squaring the x minus 2 and then taking the sine. We're taking the sine first of x minus 2 and then squaring that result. And when you look at this numerator, it looks like it may be a perfect square. And so let's try factoring it. See that x minus 2. See that minus 2 is a factor of 4. And so if we wanted to get 4 from minus 2, we'd have to multiply minus 2 by another minus 2. So this is indeed a perfect square. Okay, so this is the limit as x tends to 2 of x minus 2 quantity squared times sine of x minus 2 quantity squared. So this thing can be rewritten as x minus 2 over sine of x minus 2, this whole thing squared. Because if you remember, I'll give you a numerical example, like 7 squared over 5 squared. It's the same thing as 7/5, that entire thing squared. Okay, so hopefully that makes sense. Well, here the limit of something squared is the same thing as finding the limit of that something. So x tends to 2. And squaring that result. And you can see this form here looks eerily similar to the reciprocal of sine x over x. And now we should ask ourselves, how do we make this look like sine of x? Sine of x over x. Well, first you have to make it look like x over sine x. And what you can do is you can do a u substitution here. You can say let u equal x minus 2. And if u equals x minus 2, and the limit as x tends to 0, so this is here. The limit as x tends to 2, well, as x tends to 2, u is going to go to 0, right? Because u is x minus 2. That's the limit as u tends to 0. X minus 2 becomes u. Sine of x minus 2 becomes sine of u. So you have this limit squared. Well, we don't know this limit, but we know the reciprocal of it. Right? So we know limit as u tends to 0 of 1 over sine of u over u. this whole thing squared is equivalent to this limit here. And the limit of this reciprocal is the same thing as the reciprocal of this limit. So limit as u tends to 0 of 1 over sine u over u is the same thing as 1 over the limit as u tends to 0 of sine u over u. That's just because this is the same thing as sine u over u to the negative 1. And the limit of something to any power, in this case the negative first power, is the same thing as taking the limit first of that something and then raising that limit to the negative first power, which is the same thing as saying 1 over that limit. And fortunately, we do know this limit, right? It's 1. So that's our final answer. So the limit as x tends to 2 of x squared minus 4x plus 4 divided by sine squared of x minus 2 is indeed 1. Another thing worth mentioning is that when you try to plug in 2 here, right, so 2 squared is 4, minus 4 times 2, so 4 minus 8 is negative 4, plus 4 is 0. So you have 0 in the numerator, and in the denominator you'll have sine squared of x minus 2, so sine squared of 2 minus 2, sine squared of 0. Sine of 0 is 0, square that 0, so you'll have 0 in the numerator, 0 in the denominator, and you'll have an indeterminate form. And we just did a bunch of algebra and did this U-substitution here to get this to look or have one component of which we do know the limit, sine of u over u, limit as u tends to 0, so that we were able to evaluate the limit we were initially presented with. It's 1, so it is in fact defined, even though it looked like an indeterminate form. It does have a definite limit of 1.